Okay, today we're talking about domain, range, and intercepts. We have talked about all these things before, so you already have some prior knowledge. So just to review, domain, are those the x's or are those the y? They're the x's. And range would then be the y's. Doctor, x, y. Domain are x's, range are y's. Okay, this first problem says find the range. So when it says to find the range, they're really asking us to find what? They're asking us to find the y's, because range are y's. This is the function, and it says if the domain is -3, -1, and 7. So if this is the domain, what are these? Well, these are the x's. So if these numbers are my x's, where would I put them in this equation? I'd put them in the x's. So I'll put -3 in that x and work it out. Then I'll put -1 in the x, and then I'll put 7 in the x. And then I'll get 3 separate answers. Okay, so let's do that. First I'm going to plug -3 in. So I put -3 in this x also. 2, slap my parentheses down. I'm going to plug -3 into this x and recopy -5. 2 times -3 makes -6, and -6 minus 5 makes a -11. So that is my first range answer. So R, the first number is -11. Okay, next I'm going to find what f of -1 is. I'm going to plug -1 into both of those x's. So f of -1 equals 2. As soon as I see the x, I slap parentheses down. I'm plugging the -1 in there and recopying the -5. 2 times -1 makes -2. -2 minus 5 makes -7. And that's my second y value, my second piece for the range. Okay, and then we've got one more to find. What's the next x that we're plugging in? We're plugging in the 7. So I'm finding f of 7 equals 2. As soon as I see this x, I slap parentheses down, I plug the 7 in, and I recopy the -5. So 2 times 7 is 14. 14 minus 5 is 9. That's my last y answer, so that's my last answer for the range. Okay, so you've done a problem like this before. You just have to know your vocabulary. Domain are your x's, so you put these numbers in the x's. Range are your y's, that's what we were solving for. Now look at this next one. This one is switched around. This one says find the domain. So what are they asking us to find this time? They're asking us to find the x's. And then they tell us what the range is. So if these are my range answers, what are these? These are my y's. So I'm going to put these numbers into the y. Well, which of these is the y? Remember, f of x is just a fancy name for y. So I'm going to put the -2 into the f of x, and then the 1 into the f of x, and then the 7 into the f of x. So here I go. First I'm going to put the -2 in there. I would recopy the equals -3x plus 1. And I'm solving this equation for x because that's what I'm looking for. I'm looking for the x's, the domain. So let me circle everything smushed with my variable. Whatever's outside the circle, I add or subtract. So since it's a +1, I'm going to subtract it. My -3x would come down. My equals -2 minus 1 makes a -3. The last step, you divide by whatever is in front of that x. So I'm going to divide both sides by -3. And what is -3 divided by -3? A +1. So that is my first domain answer. All right, and then I have to do this 2 more times. So the next number I'm plugging in is this 1 here. So the 1 is going to go into the f of x, and then I recopy the equals -3x plus 1. And I want to solve this. So I'm going to circle everything smushed with my variable. Whatever's outside the circle, I add or subtract. So to move a positive 1, I'm going to subtract 1. 1 minus 1 is 0. That's gone. I bring down my negative 3x. I bring down the equals. And then on this side, 1 minus 1 is 0. I have to write the 0 this time because there's nothing else to bring down. Okay, and then to undo multiplication, I divide. So I divide both sides by negative 3. And what is 0 divided by negative 3? 0. Okay, and then I'm going to find one more. So my last x that I'm plugging, or sorry, my last y, my last range I'm plugging in is 7. So 7 goes into the f of x, and I recopy the equals negative 3x plus 1. And then my goal is to solve this for x. So I'm going to circle everything smushed with my variable. I add or subtract whatever's outside the circle. So to move a plus 1, I'm going to subtract 1. My negative 3x is going to drop. The equals drops. 7 minus 1 makes 6. And then I undo multiplication with division. So I divide both sides by negative 3. And what is that answer? It is negative 2. And that's my last x answer, so that's my last domain answer. Now you will notice I do not have these numbers in order from smallest to largest, and I'm not actually going to put them in order from smallest to largest. That way I know when I plugged the negative 2 in, 1 was the answer I got. When I plugged the 1 in, 0 was the answer I got. And when I plugged the 7 in, negative 2 was the answer I got. So I'm just going to leave them in the order that I found them. Okay. Now we're reviewing intercepts. Intercepts are where the graphs cross the x and y axis. So wherever the graph touches the x-axis, that would be the x-intercept. And the x-intercept has another special name. Does anybody remember what the x-intercept is also called? It's called the zero of the function. Wherever the graph crosses the y-axis, that's called the y-intercept. And the y-intercept has other special names too. The initial value, the beginning point, the b. Okay, so let's identify what we said the x-intercept was and what we said the y-intercept was. And let's write them as ordered pairs. So the x-intercept, this guy right here, what is its ordered pair? 4, 0. And the y-intercept, what's this one's ordered pair? 0, negative 5. Remember, x-intercepts always have a 0 for the y, and y-intercepts always have a 0 for the x. So whenever you're working with intercepts, you're going to be working with zeros, and it's always the opposite letter. When the y-coordinate is 0, that's the x-intercept. When the x-coordinate is 0, that's the y-intercept. Okay, number 4 says find the 0 of the function and the y-intercept. Well, what other word did we just say meant the 0 of the function? The x-intercept. So that's what I'm really finding is the x-intercept, and then I'm finding the y-intercept. So I know I want to be looking for zeros. So looking at this table, let's spot them. Here's a 0, and here's a 0. Now we just have to remember which one's which. When the x-coordinate is 0, we have found the y-intercept. And when the y-coordinate is 0, we have found the x-intercept, which is also called the 0. So intercepts, we always work with zeros. Okay, let's move to the next page. Now this we haven't done before, but we have enough knowledge to be able to do it. It says find the x and y intercepts of this equation. So remember x-intercepts, they always have a 0 for the y. So I'm going to plug 0 into the y. So I'm going to recopy the 3x minus 2, but where the y is, I'm going to put in a 0, and then I recopy equals negative 12. And I did that because I know if you're going to be an x-intercept, your y value has to be 0. So I just put 0 into the y. Now my goal is to solve for x. So what is negative 2 times 0? 0. It's like it's gone. All you're left with is 3x equals negative 12. If I want to solve that, how would I get rid of the 3? I would divide. And what do you get when you divide? Negative 4. So whenever you're finding x-intercepts, you should always get an answer of x equals. If you don't get an answer of x equals, you put 0 in the wrong spot. Now let's write it as an ordered pair. If this is the x, does it go first or second? The x always goes first. And what did we put into the y? 0. All x-intercepts always have a 0 for the y. Now we're going to do the same thing, but we're going to find the y-intercept. So if I want to find the y-intercept, I know that the x-coordinate is 0. So if the x is 0, I'm going to put a 0 in the x this time. So it's going to be 3, slap parentheses down, put a 0 into the x, and recopy minus 2y equals negative 12. Now I want to solve for x. How much is 3 times 0? 0. He's gone. All I'm left with is negative 2y equals negative 12. And how do you get rid of this negative 2? You divide. And what is negative 12 divided by negative 2? A positive 6. Now, if you're ever looking for y-intercepts, you should always get an answer of y equals. If you don't get an answer of y equals, you put 0 in the wrong letter. Now let's write it as an ordered pair. If this is my y value, does it go first or second? Second. And what was it that we put into the x? We put in a 0. So remember, all y-intercepts always have a 0 for the x, and all x-intercepts have a 0 for the y. Okay, this next problem is the same, it's just the equation looks different than this one did up here. So if I want to find the x-intercept, I'm going to put 0 into the y. So where this y is, I'm going to put a 0, and then I'm going to recopy. Equals negative 3x minus 9. Okay, I have to solve for x this time, so let me circle everything smushed with my x. Whatever's outside the circle, I add or subtract. So how do I move the minus 9? Add 9. The negative 3x drops. The equals drops. 0 plus 9 makes 9. What's your final step? Divide by negative 3. And how much is 9 divided by negative 3? Negative 3. Once again, I was finding the x-intercept, and I got an answer of x equals, so I'm good to go. Where does the x go, first or second? First. And what was it that we put into the y? 0. So there's our x-intercept. Okay, now we want to find the y-intercept. So y-intercepts always have a 0 for the x. So I'm going to put 0 in the x this time. So I recopy the y equals negative 3. As soon as I see that x, I put the 0 in there, and I recopy minus 9. Now to solve for y, all I have to do is work this side out. So what is negative 3 times 0? 0. And what's 0 minus 9? Negative 9. So my y-intercept, I got an answer of y equals, so I'm good there. If this is the y, does it go first or second? Second. And what was it that we put into the x? 0. So that is my y-intercept. So basically, when you're working with intercepts, you're working with zeros. So if it's a table, you look for the zeros. If it's an equation, you plug in the zeros. And if it happens to be a graph, you just look to see where the graph touches the x-axis or the y-axis. Okay? That's all for today. Thank you so much. Smiley face!